Hello everyone, welcome to my channel, The Logic of Everything. Today I'll be explaining you the analytical representation of vectors. This will require you to know the basic concepts of I cap and j cap. I will leave a link to the video I have made before in the description box. So make sure you see that video first before you see this video, otherwise you won't be able to understand anything which is taught in this video. So first of all, I'll introduce you the three axes. Consider this x-axis. Perpendicular to it is the y-axis, this one, and then this is the z-axis. All of them are mutually perpendicular to each other. They are useful for the 3D representation of vectors. Now for the start, consider only x-axis and consider a bar to be the vector. Take alpha to be the angle made by the vector with the axis. What will be the component of this vector along the x-axis? You've guessed right. It should be a bar cos alpha I cap. So if you do not understand how I resolved this vector, I'll leave a video again in the description box. Please see that video before you see this one. Similarly, now take the y-axis and take the vector as a bar. What will be the component of this vector in the y-axis? The angle given is beta. Now this component will be a bar cos beta. Another axis introduced in this video was z-axis, which is vertically upward. The component of the vector a bar along the z-axis will be a bar cos gamma if the angle between them is gamma. So if you do not understand how I resolved these vectors, I'm telling you again, I'll leave a link in the description box. You have to see that video first because that is the basic video. So I hope now you've understood the resolution of a vector a bar in along all three axes. So now if I take a vector a bar, okay, which makes an angle of alpha with the x-axis, beta with the y-axis, and gamma with the z-axis. How will you write this vector? How will you resolve this vector? First of all, as we have discussed earlier in the previous video, again I'll leave the link in the description box. You first have to shift this y-axis component. You have to do a parallel shift here. So now you have x-axis component and this shifted y-axis component. Now this is the x-axis component and now this is the shifted y-axis component. What is this? This is a cos alpha I cap and this is a cos beta j cap. Do you get this? Now what will be the resultant vector? According to the triangle law of vector addition, we know that the resultant vector will be a cos alpha I cap plus a cos beta j cap. Again, if you do not know what triangle law of vector addition is, for the 5th time I guess, there is a video that I have made before. See that first. Now we know that the resultant vector of this. So suppose you have this vector. This is x-axis, this is y-axis. You shift this here. So you know what the resultant is going to be. The resultant is going to be in the xy plane. It is going to be in the xy plane. Now the third step is that I have to shift the z-axis component like that. So there has to be a parallel shift for the z-axis component, so that the z-axis component will be like this. So now if you can imagine 3D, this is our resultant vector which we just found out, a cos alpha I cap plus a cos beta j cap. This is that vector. This was the x and y axis, and this was that vector. Now after parallelly shifting the z axis component, you have this, and now you have the original vector which was like that. So now what does the triangle law of addition tell you? What does it tell you? This is the z-axis component and this is the one we found out. So the final component will be a bar, which is our original vector will be equal to this plus this, according to the vector triangle law of vector addition. So what was this? A cos alpha I cap plus a cos beta j cap, right? And this is, yes, you guessed it right, this is a cos gamma k cap. So we can write a bar now as a cos alpha I cap plus a cos beta j cap plus a cos gamma k cap. As simple as that. So you have to know this equation because it is very important in solving different types of sums. Now another thing you have to know is that according to the Pythagoras theorem, now what will the Pythagoras theorem tell you? The Pythagoras theorem will tell you that the magnitude of this vector will be root of ax square plus ay square plus az square. So this is according to the Pythagoras theorem. I will explain you how. So these are the three axes, we know about them. This is our vector, right? Then this is our x component, this is our y component. So when we shift this y component here, what will be this vector? This vector's magnitude will be this square plus this square. Again, for the final vector, it will be this square plus this square. So the final magnitude, as we just found out, will be this. I hope you've understood what I just taught. So if you have any doubts, please ask them in the comments section. If you like the video, press the like button and please do subscribe. Thank you.